Hello, and welcome back to another episode of Brain Planet, the world's only nature psychology documentary. Today, we are going on a brain safari and touring different parts of the jungle that house different parts of the brain. Let's go!
Welcome to our first stop, the parietal lobe, represented by this family of monkeys. The parietal lobe is responsible for processing sensory information from different parts of the body through touch, understanding spatial awareness, and is also responsible for processing numbers in mathematics. See how these monkeys do the same thing for their family by gathering and counting enough bananas for everyone? Well, I guess these monkeys have damage to their parietal lobes because they're lacking in the spatial awareness department.
Our next stop is the temporal lobe. This lobe mostly affects memory. As you're about to see, a rat will represent just how important memory can be. Look at this rat. This rat is currently trying to find its way through the trees back to its house. As it goes through the trees, it is able to easily remember the path it has taken. In turn, it uses this to its advantage and is able to get through the trees. The temporal lobe also affects speech and musical rhythm, but rats are not able to speak or create music, so we cannot show that here.
The occipital lobe is our next location. This lobe is responsible for what you see, perceive, and differentiate between. It helps control the visual pathway and an important skill for people in the jaguar you are about to see. Jaguars have excellent night vision for hunting prey like rats.
Welcome to the middle part of the jungle and the middle part of the brain. The brainstem is made up of the midbrain, the pons, and the medulla. The medulla is the lowest part of the brainstem and keeps your heart beating and your lungs breathing, much like this river that keeps all the jungle animals alive. The pons is responsible for balance and many facial and eye movements, and the midbrain as well. In addition, the audio and visual processing represented by this jungle owl, since owls have excellent vision and can turn their heads all the way around. Hoo, 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 hoo.
Now, to the largest part of the brain and the largest part of the jungle, the frontal lobe. This part is responsible for personality and movement. As you can see here, this parrot likes to hang out in the trees. It is able to flap its wings and move from point A to point B and has its own personality. Some parrots are timid and aggressive, positive and humorous. This can be important to their interactions with humans and other animals. Does Polly want a cracker? Welcome to the spinal cord, which is essentially a bundle of nerves at the bottom of the brain. These nerves connect to other parts of the body and send out brain signals to tell those other parts what to do. This can be demonstrated by a tree frog. This tree frog's brain sends signals to its legs to determine the power of its leaps. It also uses brain signals to understand where it can hide and camouflage. The spinal cord is one of the most important parts of the brain and is included in animals with vertebrae because it allows them to move and react.
Here, the cerebellum and the cerebrum are in charge of complex sensory movement and neutral functions. This is where hand-eye coordination comes into play. Much like a snake has great reflexes when catching its prey, and it uses complex movement in its stomach to move across the ground quickly.
I'm a snake.
Our next stop is the thalamus and hypothalamus. The thalamus is in command over alertness, sleep, and consciousness. The hypothalamus is in charge of releasing of hormones. Here we see this demonstrated by this fly. Whenever it sees something coming toward it, it is able to be alert and quickly move out of the way. The fly then proceeds to bother other animals near it. These animals quickly release hormones to express that they are angry and proceed to try and get rid of the fly. Welcome to the amygdala. The amygdala is a small part of the brain responsible for emotions, emotional perception, and fear response. This is the flight or fight response kicks in, demonstrated here by this elephant and this mouse. Even though the elephant is infinitely larger than the mouse, it runs away in fear because its brain only has a moment to decide if the mouse is a threat or not.
Our next stop is the hippocampus. This is a small gland in the brain that allows us to form new memories and affects our learnings and emotions. Here we see a newborn giraffe and her mother. The newborn giraffe is learning how to walk and how to live while also creating bonds and emotions with her mother. This is also starting to make new memories of its first part of life. It takes a while for humans to have their first memories, but the hippocampus is responsible for it.
Here in Broca and Wernicke's area, it's all about speech. This area of the brain is close to the auditory cortex. Specifically, Wernicke's area listens and processes the sounds it hears, and Broca's area generates the speech. However, some people experience damage to those areas of the brain, and it causes speech disorders, represented by these lions having some communication problems.
Roar! 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 Wolf!
Roar!
Now we are in the reticular formation part of the safari. The reticular formation is the part of the brain that is responsible for the sleep-wake cycle and your attention span. This is demonstrated here by this koala. As it sleeps, its brain is resting, but when it hears a loud predator coming through the jungle, the reticular formation wakes the koala and alerts it of danger.
And we're back at the river. This is our last and final stop, the corpus callosum. It is responsible for sending alerts to the cerebral cortex, acting as a bridge between these two parts of the brain. We are representing this by the bridge over the river that connects two parts of the jungle. We hope you have enjoyed our Brain Safari documentary here on Brain Planet.